Just 71 miles north of Puerto Rico lies the Puerto Rico Trench, a remarkable geological formation plunging nearly 27,600 feet beneath the ocean's surface. This makes it the deepest point in the Atlantic Ocean, so deep that Mount Everest would be completely submerged if placed inside. The trench marks the boundary between the Caribbean and North American tectonic plates, creating a zone of intense geological activity. Its proximity to major U.S. East Coast states like Florida, New York, and the Carolinas means understanding this trench is vital for the safety of millions living along the Atlantic shoreline. What makes the Puerto Rico Trench especially significant is the ongoing collision between the Caribbean and North American plates. This interaction not only shapes the seafloor, but also generates considerable seismic and tsunami hazards. Studying this unique environment is essential for grasping the natural threats that could one day impact vast coastal regions, including the U.S. East Coast. This tectonic boundary, the North American plate gradually subducts beneath the Caribbean plate, building up immense geological stress. When this stress is released, it can trigger powerful earthquakes, sometimes exceeding magnitude 8.0. These seismic events have the potential to displace enormous volumes of water, sending tsunamis racing across the Atlantic and putting distant communities at risk. A powerful example of the trench's destructive capacity occurred on October 11, 1918, when a magnitude 7.5 earthquake struck off Puerto Rico's western coast. The violent shaking damaged infrastructure and almost immediately triggered a tsunami. Waves as high as 20 feet crashed ashore, devastating coastal communities and resulting in the tragic loss of 116 lives. This remains one of Puerto Rico's most significant disasters, underscoring the region's vulnerability to both earthquakes and tsunamis. The impact of the 1918 tsunami extended far beyond Puerto Rico. While the island suffered the greatest devastation, the tsunami's energy traveled across the Atlantic, with waves detected as far away as the Canary Islands. This event illustrates how seismic activity in the Puerto Rico Trench can have far-reaching effects, threatening coastlines well beyond the immediate region. Beyond earthquakes, the Puerto Rico Trench is also associated with underwater landslides. When large sections of the seafloor shift or collapse, they can rapidly displace huge volumes of water and generate powerful secondary tsunamis. These landslides often occur with little or no warning, making them especially dangerous for coastal populations and complicating emergency response efforts. To assess these hazards, scientists have developed computer simulations modeling the aftermath of a major event in the trench. These studies reveal that a large earthquake or underwater landslide could produce tsunami waves up to 80 feet high, racing across the Atlantic and placing over 100 million people along the U.S. East Coast at risk. This underscores the critical importance of preparedness and public awareness. Simulations also highlight the speed at which disaster could unfold. In the event of a major tsunami, waves could reach Florida within 2 hours and New York in just 3 to 4 hours. With such limited time for evacuation or emergency response, robust warning systems and preparedness plans are essential for the densely populated Atlantic coastline. Despite these looming threats, there is a significant gap in tsunami preparedness between the Atlantic and Pacific coasts. Pacific regions have developed comprehensive emergency plans and public education programs due to their frequent tsunami history. In contrast, Atlantic cities like those in Florida, New York, and the Carolinas have generally placed less emphasis on such measures, leaving millions especially vulnerable. Recent scientific exploration has greatly expanded our understanding of the Puerto Rico Trench. In December 2018, the Five Deeps expedition achieved the first crewed descent to the Milwaukee Deep, gathering valuable data on the trench's depth and geological features. Continued seismic activity, such as the magnitude 6.4 earthquake north of Puerto Rico in 2014, serves as a reminder that the dangers associated with the trench are ongoing. These advancements emphasize the need for ongoing research and preparedness for all at-risk communities. The dangers posed by the Puerto Rico Trench are not hypothetical. They are real and well documented. Despite past disasters and ongoing seismic activity, public awareness and preparedness along the Atlantic coast remain insufficient. As scientific understanding advances, so must our commitment to proactive risk reduction. By investing in education, early warning systems, and comprehensive emergency planning, Atlantic coastal cities can better protect their residents from future disasters. Taking action now is crucial to avoid being caught off guard by the next major event.